Welcome back. This is your favorite computer science and coding teacher, Mr. Pitts. We just wrapped up lesson 2. If you missed the previous videos and you need help with lesson 2, go back, check those out, and then come back to this video here because we just passed the assessment. It was quite the challenge mentally and emotionally, but not quite physically, right? We're sitting in front of a computer, but it was a challenge, and we did it. So we're gonna move on to lesson 3. So we're gonna, once you hit completed over here for the challenges and the assessments, we're gonna come up here, and yes, we are in lesson 3, which is all about logic. Now, but before I head over and talk to this NPC, one of the things I will point out is that in between lessons there is a computer or a robot or something. It's turning and looking at me, so I'm assuming it's some sort of robot. But anyway, you right-click that, and it will take you to the beginning of whatever lesson you would like to go to. So this will teleport you, obviously not lesson 3 because we're in lesson 3. But again, don't skip ahead. There's no point in that. You have to do the work and do the assignments and turn those in. But if you ever get down the road and get lost and need to come back, then in between lessons there are these robot lesson teleport things. So all right, first NPC. Again, give this NPC a name. Make it something appropriate. Make it something fun. Throw it in the comments. Definitely want to see that. So when we talk to this NPC, we're moving on from variables, lesson 2, to logic, lesson 3. Logic is the next huge concept in computer science. It is used in computer programs when you need to make a decision and possibly take one of many paths based on the decision. So think about any of the computer programs that you use, the computer games that you play. They're going to use logic to do things based on certain factors. Logic can also be known as selection. So we're going to go down a different path. Think about a decision you had to make today and the actions that led to and the actions that you would have had to take if you had made a different choice. So, for example, is today a school day? When you woke up, your feet hit the floor, you said to yourself, is today a school day? Am I going to school? Am I going to work today? If the answer to that is yes, a series of things begins to happen in the program that is your life, like getting ready for school or work. Think about, taking the shower, brushing your teeth, putting on clothes, getting the breakfast, getting out the door for the bus, for the car, whatever it may be. If the answer to that question is no, it's not a school day, then we're not going to do half of those things. We're certainly not going to put on work clothes. We might do yard work clothes if it's a Saturday. We might do church clothes or something, and if it's a Sunday, who knows? We might put on trampoline park clothes if we're going for one of those things. But so the day of the week will dictate, is it a school day, is it not? Will dictate what program we're going to run. So that's what logic is all about. So we're going to add the logic drawer to most of our activities, and it's going to be used to make a choice between 2 or more complex decisions and involving many pathways or options. So when we make choices, we often need to compare 2 items. So for example, you may want the route you take to school to be the shortest. So that way you would compare the distance between this route and that route, and then you would say, well, let's go with the distance that is the shortest. We can compare 2 variables, and then we can use that in our decision-making process. If-then statements. So again, back to my example. If today is a school day, then we will run the getting ready for school program. The most basic form of decision making is the if-then block. It allows you to make a decision whether to perform an action based on whether or not a condition is true. So for example, look at the flow chart below, and then we can visualize a choice that if a condition is met, the action is performed. If it is cold outside and that is true, then we will wear a jacket. If then blocks are in make code, found in the logic drawer. So then we're going to use some comparison operators. We're going to compare this thing to this thing. Sometimes it will be comparing two variables. Sometimes it will be comparing a variable to another value. But in any case, we're going to be comparing things to find out if that thing is true. And then if it is true, then we will run the code that's inside of there. When we open up the comparison blocks, there are multiple operators. There's an equal to, a not equal to, a less than or equal to, a greater than, or the greater than or equal to. These are probably familiar from your math class. The equal to operator compares and checks two things to see if they are the same value. If they are the same value, then the whole diamond will be true. If they are not the same thing, then the whole diamond will be false. Not equal to is the inverse. So it will compare two things. If the two things are not equal, then the diamond is true. If the two things are equal, the diamond is false. Less than or equal to, greater than, and greater than or equal to. Again, we're doing comparisons to determine, is the diamond returning a value of true, or is the diamond returning a value of false? So let's get into some practical use and application. Walk into our wrestling ring and start activity 1. So we're going to use if-then blocks to add some functionality to the game. We'll create a program that will allow the agent to move forward 4 blocks and destroy any blocks along the way. So we're going to change our chat command to forward. Going to go to the logic drawer, grab an if-then. By the way, there are 2 versions of that. There's the if-then, and then there's the if-then-else. The difference between the two is that the if-then, if this is true in the middle, if the comparison is true, then we're going to run this code. If it is not, we just go on to the next code, the next line in the series of code. However, if we have an if-then with an else, if this is true, then we'll run the code that's in here. If this is not true, we'll skip this code and run this code instead. So we have 2 situations. One is if we want to run this code when this is true. And the other situation is where we want to run one of these 2 sets of codes based on whether or not this is true or false. So we're going to go to agent. We're going to go to agent detect block. Now, one of the things that you'll notice is that the agent detect block is this diamond shaped block instead of this flat shaped block with the divot in it. And what that means is that you cannot put it there as a line of code. It's an agent detect, and it will return true or false, a boolean value, true or false, depending on whether or not there is a block in front of the agent. You can change it to block or redstone, and you can change forward to any direction, any of the 6 directions. So when we put this agent detect block here, what's going to happen is the agent will, when we run this line of code, the agent will run this detect block forward. And if that returns true, then we will run the code that's in here. If it does not return true, if it returns false, there is no code there, then it's going to move on and start running the next line of code after the if. It'll skip this part. So now we're going to place an agent destroy forward. If there's a block in front of the agent, and that is true, then we'll run this code inside, which is to destroy that block. Then we want to add an agent move forward behind that, but they want that after the if-then. Because what that means is if there's a block in front of the agent, and that is true, then he will destroy that block, and then he will move forward. If there is no block in front of the agent, then we will skip the destroy forward line of code and just do the move forward. So regardless whether there's a block in front of him or whether there is no block in front of him, we're going to end up with the agent move forward by 1, just like that. All right, so now we're going to test the code. Is there a block in front of the agent? The answer is yes, so I would expect him to destroy that block and then take a step forward. Just like that. Just like that. Now there's our screenshot for activity 1 for lesson 3 right there. Move forward if we'll destroy, and then we move forward either way. Now we're going to head over to activity 2. Now that the agent can move forward, we're going to add some more make code to allow the agent to do it 4 times. So what it says is to right-click on the if-then block and then select the duplicate option. Drag the duplicated series of blocks and place them after the agent move forward by 1. Then we're going to duplicate the move forward by 1. And then we're going to repeat that process 2 more times. So again, if I had use of all of the blocks, I would go to loops and I would use that repeat block that we used in the last assessment and just do a repeat 4. But for now, we're just going to leave it the way they want it. If we need to zoom out, if our code gets too big, we can always hit this minus or plus and zoom it out. But on chat command forward, it's going to do the detect. If it's true, it'll break, then he'll move. If there's a block, we'll break it, then move. If a block, break it, move. If block, break it, move. So we've got a total of 1, 2, 3, 4 moves and a total of 1, 2, 3, 4 if-then statements. Does that look right? Yes, it does. Now let's test the code. So instead of running it 4 times, we're going to run it just once. There we go. So there's your screenshot for activity 2, lesson 3. Now, by the way, there are no blocks in front of him if we do the forward. He's still going to move forward. He just won't break any blocks because there aren't any to break. So, all right, so we're going to complete and move on to the next section. So the wall opens up magically and mystically and wonderfully, and we head over here to another NPC. Again, make sure you're giving these NPCs names in the comments. This one looks like maybe a flower in the hair, or a hair bow or accoutrement of some sort, some type. And now we're going to get into the comparison operators that we alluded to earlier. Comparison operators allow you to compare two variables or two values and determine if they are equal, not equal, less than, greater than, equal to, all of those things. Okay. The comparison then results in a boolean value, true or false. The comparison is either true or false. Even though the comparison can be set up in any number of ways, it will ultimately boil down to, is the comparison true or is the comparison false? There is no other answer. They're used as conditions for logic. We're going to run this if it's true, or we're not going to run this if it's false. So we're going to step into our ring and click on activity 3. What we're going to do is create a program that will track the number of a chosen type of block placed. So there's going to be a variable, which we mastered in the last lesson, to track the number of blocks placed, which we will then update when we place or destroy a block of the chosen type. All right, so we're going to go to the variables drawer, create a new variable called no, which would be number of blocks placed. And you recall from an earlier video, this is called camel case, right? Makes it easier for us to read when we capitalize the letter, since we cannot have spaces in our variables or our chat commands. So there's a variable number of blocks placed. Go to the blocks drawer and drag out an on block placed and change it to stone. If you cannot find a block, you can type that in here. All right, change that to stone. From the variables, we're going to grab a change variable block. And make sure that this is number of blocks placed. So when a stone block is placed, we're going to run this code, which is to add 1 to the variable number of blocks placed. Whatever is stored in that value will be increased by 1. As you recall from the last lesson, a lot of this was involving grass blocks, and there's an issue with the content ID, so the game was updated to run on other blocks other than grass blocks. So that's why you still see grass block in there as a typo. They fixed a lot of these activities, but sometimes the text is still referring to the old grass blocks. All right, every time we destroy a block, we want to reduce that number. So if we place 5 stone blocks and then break 2 of them, that would be 5 minus 2. We want our variable to be 3. So we also have to bring out an on block broken. Again, change that to stone. And then do a set variable. Well, it says set variable. Oh, we're going to do that. Set variable. This is the second way to change a variable. We could have done change by -1, but let's do this. This is more interesting. I like it. So we're going to change the variable, the number of blocks placed, and place a subtraction block from the math drawer. So go to the math drawer, grab a subtraction block, and place it where the number 0 is. We're going to add the number of blocks placed variable there. And then we're going to subtract the number 1. So basically what this is saying is we're going to set the variable number of blocks placed to contain the value of the answer of number of blocks placed minus 1. So again, if we placed 4 blocks and number of blocks placed is equal to 4, and then we break 1, we're going to do 4 minus 1, which is 3, which gets assigned to that number of blocks placed variable. So this increases the variable value when we place a block, and this reduces it when we break one, which is exactly what we want to happen. All right, so now we're going to use our cheat where we put something in the chat to see what the variable is. We're going to grab our join like we did before. And then what we're going to do is we're going to change hello to number of blocks placed. And again, put a space after that. So we got a space in between that and the answer. And then we are going to drag the variable number of blocks placed and put that there. What this is going to do is this is going to say the combination of the number of blocks placed and the value of whatever that variable is. Whether it's 2, 8, 97, whatever that value is in number of blocks placed will be said in the chat. Okay, now we want to have an on start. Go to the mobs drawer. Drag that thing out. All right, we're getting a little, try to keep these organized here. So we can see everything. All right, so on start, we want to give the nearest player and change that to yourself. Then we're going to change this to stone, and then we're going to change the amount to 64. Why 64? Well, there's a long answer and the short answer. The short answer is that's the most, that's the highest number of stone blocks that you can contain in any one inventory slot. The reason for that goes back to the fact that there are 8 bytes or 8 bits in a byte. but we're not going to get into that today. So just know that the max number of stone blocks you can hold in one slot is 64. You can't own you can't put any more than that in one slot. So we're going to set it to 64, which is the max. Okay, so we have our on start. We're going to give ourselves a stone. If we place one, blocks goes up by 1. If we break one, blocks goes down by 1. Now we're going to test it. So keep in mind, we're not using a chat command for this one. This is the first activity we've run. We have not used a chat command. You can actually get rid of it. When we press the start button, this code will run. Then it will wait for these events to do these lines of code. Noticed how those stone blocks just popped up into my hotbar there. Okay, now when I place a stone block, it should update the value of the variable and also put something in the chat. Number of blocks placed 1, number of blocks placed 2, number of blocks placed 3. Now if I break one of these blocks, it would be nice if I had a pickaxe. Is there one in the chest over here? No. Okay, so it would be nice if I had a pickaxe. But if I break this block here, what that should do is subtract 1 from the variable number of blocks placed. This should subtract another one from the variable number of blocks placed. So I would expect, even though I didn't put a say in that code, that the value inside the variable number of blocks placed is what? 1. Because that's it. We placed 3, we broke 2, 3 minus 2 is 1. So if I add another one, I should get number of blocks placed 2, which we did. So we know the code is working correctly. All right, so that's activity 3. Again, just make sure that we get your screenshot if you're turning that in for credit. And now we're going to do activity 4. So what we're doing again is we're working with the same code from activity 3. We're going to extend our learning, and we're going to use comparison operators to enhance the functionality of those if-then blocks. This program is going to track the number of a chosen type of block placed, and every time we place 5 blocks, we will put the say in the chat. So we're going to create a variable to track the number of blocks placed, which is what we did last time, and then we're going to update that when we create or destroy a block, and then when that variable reaches a value which is divisible by 5, we will tell the player the total number of blocks currently laid. Remember, in the last activity, it was basically putting something in the chat every time we placed a block. That gets quite spammy. So what we want to do is set this up so that it will only update us on the value of number of blocks placed in the chat if it's a multiple of 5. So every 5 blocks. Less in the chat makes us happy, right? All right, so we're going to go to the logic drawer. We're going to grab an if then, and we're going to place it around the say block right here. Okay. Got it. Then we're going to grab a comparison block. Again, the logic, the if-then block makes no sense unless we are going to put something here as a comparison. Because if true is always true, it will always run this. There's no point for to have the if we leave it as true. So we have to add a comparison. So we're going to grab a comparison, and we're going to drop it right where the true goes. So then we're going to go to math, and we're going to do a remainder. You have to know a little bit of math to do computer science. Remainder is the number that's left over when you do division. So for example, 11 divided by 5 is 2 with a remainder of 1, because 2 times 5 is 10, and that leaves the 1 left over. All right, so we're going to go from variables, grab our number of blocks placed variable, and place it on the 0 in the remainder of 0 divided by 1. So again, you have to be careful where you're going to let this thing click into, because it'll click into and it will sort of show you as you're dragging where is it going to connect. You don't want to replace this. You just want it to replace that 0. And then we want to find out what's the remainder of number of blocks placed divided by 5. If that number, the remainder of number of blocks placed divided by 5, is equal to 0, then we're going to run this code. If the remainder of number of blocks placed divided by 5 is anything other than 0, then we're not going to run this code. That's the power of the if-then logic block. So now let's test the code. Let me reset the area. And then I'm going to go back in, run the code again, just to make sure we're all even. All right, so I would expect that I won't see anything in the code until I've placed 5 blocks. So let me start in the corner. 1, 2, 3, nothing in the chat yet. 4, and then 5. Number of blocks placed is 5. 6, 7, 8, 9, 10. Then I can break a block. Eventually it'll break. Yes, and then it broke. So then number of blocks placed should be 9. And if I place one more, I'll see 10. Right? 11, 12, 13, 14, 15. So again, instead of seeing it in the chat every time we place a block, we're only seeing it every 5 blocks. So this is the screenshot for that activity 4. All right, once you've completed that activity, we're going to head on to the next section. All right, we've got an NPC here, maybe in a blazer or a lab coat of some kind with some eyeshadow. Anyway, this one looks very professional. This is the challenge assessment. There are not 2 parts like there were in the second challenge. There is only 1. So lesson 2 had 2 parts. Lesson 3 only 1, which is good. Also means you got to get it right. So again, step 1, talk to the NPC, even though we're probably not going to use them unless you are linking to the website for credit on codingcredentials.com. Once you talk to that NPC, then the wrestling ring will turn yellow. If you don't do that, you don't get the agent, you don't get the yellow. It doesn't really work that great. So make sure if you have a little thing that says talk to the NPC, that you talk to the NPC. All right, here it says complete assessment. So what is the challenge? Using MakeCode, yes. Can you? Well, yes, we can. So just using MakeCode, you will create code which responds to the chat command destroy grass. This code should have the agent walk down the center of the 2 sets of blocks and destroy only the grass blocks and not the cobblestone blocks. Don't forget to upload your MakeCode file to the portal when you finish. If your instructor has you doing that, make sure you do that. So, so let's chat about this real quick. If you've been following along, you know that one of the issues that the program has had is that the content ID for the grass block was sort of bugged in a recent update. So what we're going to do is the opposite. We're not going to destroy grass. We're going to destroy cobblestone instead of grass. Okay, so that's edit number 1. Go ahead and write that down. Just jot that down. Jot that down. Okay, so we're gonna where'd I go? Okay, here we go. So we're going to not destroy grass. We're going to destroy cobblestone and leave the grass. Grass is nice. We want grass. We need to touch grass from time to time, right? Oh, that feels good. Yep. So we're going to destroy the cobblestone and not the grass. Secondly, let's think about the actual algorithm for what the agent is going to do. First and foremost, the issue is we want the agent to walk down this aisle. The agent is not in the aisle. So step 1 for this really needs to be, let's get the agent over here to the point where they're in the aisle, right? So I would, oh, I got this thing where I'm popping up here. All right, so I would get the agent over here into the aisle first. Then what you're going to do is you're going to run a check. If this block to my left is cobblestone, then I will break it. If this block to my right is cobblestone, then I will break it. Move forward by 1 and repeat. If this block to my left is cobblestone, then I will break it. If this block to my right is cobblestone, then I will break it. Move forward by 1 and repeat all the way down the line. So we're going to be doing that 1, 2, 3, 4 times. All right, so go get your algorithms right. If you need to touch grass, and I don't mean Minecraft grass, like actual grass, go do that and then come back. But go ahead and give this assessment a try. Again, it's one of those that is not a ton of code. It's just a few short lines with logic and a repeat. So again, what you want to do is, once you've got your agent in here, is press C, create new project, name it something specific. So your name, lesson 3 assessment, and then hit create. So then you're going to take the algorithm that you just wrote down, code that in blocks, and then turn that in. All right. What I'm going to do is upload a lesson 3 assessment supplemental. That way, once you've done it, you've gotten your answer, and you just want to double check to make sure that it's the right and best answer that you can get. Then you can go ahead and check out that video and see that answer there. So again, thanks. I hope you enjoyed lesson 3 of intermediate coding in Minecraft. It's a fun one. Logic is absolutely huge. As a matter of fact, I got my double major in philosophy because of logic. So computer science and logic really go hand in hand. So once you get variables under your belt, we got to get logic. So yeah. Thanks again for hanging out. We're going to do a lot more logic. Make sure you get your assessment done. Then go check out the supplemental video to make sure that you got it correct. And we're going to move on to lesson 4. After that, man, we're making some progress. So thanks again. See you in the next video. All right. Bye.